focus, though, is around Flume and the information that people are storing in big data problems, scaling it out. Many people run Solr with a single server. We're much more interested in that distributed solution, taking advantage of the capabilities that have it in between for that large amount of data. Not that it would work, this one's going to provide.
Hi, one of your slides mentioned is with the same box of the MapReduce cluster. So do you have the HBase instances on the same MapReduce cluster, or do you have separate instances of HBase in your environment?
Yeah, that's a great question. So the idea is that you have this simplistic framework. You have a bunch of resources on your Hadoop cluster. And you're able to carve out to decide what you want to run on that cluster. You're probably putting a bunch of data in there. Most people run IAK or MapReduce jobs to do analysis. If you decide that you want to do search additionally, you can turn that on. The same thing with HBase. But today, if you're running HBase, you can co-locate it with data node. You can put Solr on there as well, running as a process. It really is going to depend on your use case. How much are you taking, how much resources are you putting into HBase? How much resources do you want to put into HBase? Versus how much resources do you want to dedicate to Solr? If you want to max out the box with HBase, you want to max out the box with Solr, it's not going to work. But if you're saying like, hey, we have this amount of load from HBase, this amount of load is going to come from search, it makes sense to co-locate those two processes together. At the end of the day, you're going to be running MapReduce jobs in the background. You're probably going to run across all the machines, right? So you need to do some thinking, some planning. At Cloudera, we're working on that. So Cloudera Manager already supports things like C groups to allow you to partition between, say, I want to guarantee that HBase is going to get 50% of the CPU. I want to guarantee that search is going to get the other 50%. And if we're competing at both 50%, one is running, the other isn't going to get or whatever the C groups is working. So we already have things like that that we're shipping as part of our solution. And there's another knob that you can turn to kind of control these things across multiple resources. I gave you the CPU example. There are other resources as well. We'll continue to work on those kind of things.
Okay, we have one more question here.
Right. Have you done a comparison with Elasticsearch? Have you done any comparison with Elasticsearch with a lot of read writes, read writes?
So the question is, how does this compare with Elasticsearch? Again, so Elasticsearch today does not have integration with HDFS. They have the capability of copying their indexes onto HDFS. So if you have a catastrophic failure on your cluster, you can recover from that particular solution. Oh, what's the impact of performance on performance? So what we looked at is what happens when you run Solr on the local disk, and then on that same machine, you run HDFS and Solr with our solution. What we found is that the performance was comparable. So the indexing performance that we saw was comparable. Query performance was comparable. It's really going to depend on your environment. So if you're a sophisticated Solr user, you might have machines that have RAID, but many people just run on a single disk. The Solr itself, Lucene, typically wants bandwidth or disks. So in Hadoop, you're running on top of HDFS that's going to carve up everything into blocks. And you're typically going to have multiple drives. You're going to have 10 or 12 drives on each node. So you're actually being able to take advantage of the striping that is inherent in the HDFS solution. So when your Solr instance is writing to HDFS, it's actually getting striped across all the drives. Typically, you don't see them. Again, we use comparable hardware. We actually use a small number of drives to keep things fair. And we actually saw that the indexing performance was comparable when we ran Solr on the local drives versus Solr in the HDFS solution. Now, that's not to say we tried every possible use case with every possible resource management intensive process going on in the background. We loaded down the cluster with a MapReduce job, and all the slots are taken, all the CPUs are taken. Obviously, you're needing resources versus a dedicated cluster that you might be running with Solr or Elasticsearch or HDFS or whatever the case may be. The other thing that you need to keep in mind is that these other solutions need to copy your data somewhere. It's a huge headache to maintain 2 copies of all your data. So if you've got Elasticsearch running off here on some other cluster, you're copying data over there in order to get that index. Here you're running everything on the same cluster. If you make a mistake, oops, I thought there were only 3 shards, but I really need 10. You run a MapReduce job, re-index everything in a short period of time and try that out. You can't do that with these other solutions. So I would say that's one of the biggest things. HDFS gives you a whole bunch of other, I couldn't get into everything because it would be a quite longer talk. But HDFS gives you all kinds of other things around robustness, provisioning. You can shut down the Solr server on one machine and bring it up on another one. Maybe you bought some new machines and added them to your cluster and they have places many CPUs. You can just shut one machine down and bring it up on the other. You don't have to do backups because everything is being replicated in HDFS. If you are running a regular Solr cluster, you have to figure out how to get back up everything. How am I going to migrate when I do need to extend my cluster? So there's a lot of capabilities that you're not getting with these other solutions, regardless of whether we look at Elasticsearch. Elasticsearch is a great product, but it just doesn't fit all the needs that our customers have. It's a great product. The other part of that is that if you look at the type of processing that's happening on the indexing side, it tends to be very CPU intensive. It's much less so around IO intensive. And it has pretty high bandwidth when you're streaming out files in a serial fashion. So that all fits in really nicely as well. So our experience so far, we sent your public beta pretty recently, and like I said, go try this stuff out, tell us about use cases that we haven't tried. But we've tried this out with some use cases. I'm sure we'll find some things where it works better, some things where it works less smooth. So far, it's worked pretty well for us and for our customers that we use it.
So I'm KRS mostly. Sometimes you don't want to do exhaustive search. You want to find few instances only of whatever you're searching, a string or a contextual search that you want to do. Can you specify and limit the resources you want to use it many times? That is especially if it's in the cloud, you don't want to put it.
Sure. Well, the way search works is all oriented around the search engine result page. And that first page that you get back in the result is typically something on the order of 10 results, maybe 50 results. Oftentimes you will allow configuration of the queries in preference. I always want 50 results, but I always want 10. It's just an inherent way in the way Solr works, at least the way Solr works, the way Lucene works, that you get that limitation. So what ends up happening is you run the query, you get a list of potential document matches. When you score that, you find out what are the 10 best. And if you're only running a single Solr server, your query goes to that server, and you get 10 best matches back, unless you ask for more. So that's already happened. The other is the scatter-gather effect. So if you need to partition your data across multiple servers, because the amount of documents that you have is too large to fit on a single server. You're talking about HDFS, right? Large amounts of data. In that particular case, you do much more of a scatter-gather. So you run the query against one machine, and it coordinates that activity. So if you have 10 charts, or 10 queries in parallel, it'll get the 10 best matches for each of those guys, and then it'll cause up the results to give you 10 best of the result. So that's essentially how it works. And it just kind of works that way out of the box. If you ask for 100, you get more. But by default, I think it's typically on the order of 10. Was there anything else? All right. Well, I want to thank everyone for coming in today. Really appreciate it.
Thank you for your work.